In this video we're going to be discussing sigma notation. And sigma notation is just a kind of a neat and compact way of writing a series. And of course a series is just the sum of the terms of a sequence. So I'll start you off with the actual Greek letter here. It's an uppercase Greek letter. And even though it looks like E, it definitely is sigma and it means sum. Some of you who are familiar with like Excel or something like that, you'll notice that that symbol is used to represent an auto sum or a sum in Excel. So there's a few different parts to sigma notation. Let's start with one part, which is the variable you use. And it's normal to use n, but you can really use anything you want. You could use I or k or any variable is okay. And this is called the index of summation. It's the actual variable. You will always start at a value. And you're going to start at an integer only. You can use any integer, but it will be an integer. And let's start this one off when n is equal to 1. So this is called the lower limit. And it's kind of like your starting value, so I'll put that down here. This is like a starting value. We need to know the upper limit, or when you stop, and so that number goes up here. We don't have to write the index of summation twice. It only appears in the bottom in sigma notation, but we just need to write some number up here again, some integer that has to be bigger than the lower limit, and we'll call that the upper limit. And the upper limit is kind of like your ending value. Now, we also have to have something to sum up. So that something is called the general term, and the general term would appear just to the right of sigma notation. So let's do 2n plus 4. Now, if we were actually doing this problem, what we would need to do is we would need to take 2n plus 4 when n is 1. So that would be 2 times 1 plus 4, which is also equal to 6. And then we can kind of think of that as the first term. Then this is a summation symbol, so we need to add the next term, and instead of n being 1 this time, n is going to be 2, the next positive integer, or at least the next integer higher than 1. So the next one we need to add up is 2 times 2 plus 4. All we're doing is we're just substituting now 2 in for n, and that's the next term that we add up. So this one's going to be 8. 2 times 2 is 4 plus 4 is 8. The next one, you might have already guessed this, so we used 1 here. That's always the start or the lower limit. And then we're going to use 2 next, and 3 would follow that, and we're going to stop at 4. So I'll go ahead and write out everything here. And let's see. So that should be it, I think. And that is 6 plus 4, or 10. And then 2 times 4, which is 8, plus 4 is 12. And so then the last thing to do is to actually add these all up. And so you would add 6 and 8 and get 14. 14 and 10 is 24. And then 12 would be 36. So if you were looking for the answer, if you're asked to evaluate this sigma notation, your answer here would just be 36. Now I mentioned before that you don't need to use n as a variable. You could use x or I or anything else that you want, but you do have to make sure that this index of summation is the same variable that appears here to the right. If it's not, then it's not really that proper to substitute n is equal to 1 for k here. You would want to make sure that those are the exact same variable. Also note that the n value can be something different than 1, but it's going to be some integer. Also for this one, the upper limit's got to be bigger than the lower limit, and it's going to be another integer, so no fractions are allowed here and no decimals. Let me just write this a little bit differently for you, and we're gonna come up with the exact same sum and the exact same series here, but I want to show you how that can look a little different, but really is the same thing. So I can write that, maybe we'll do that right down here. So I'll write the sigma notation, or the sigma, the Greek letter sigma. We're going to start this one for, we'll just go k is equal to 3, and then that's our lower limit, 3, and then our upper limit will be 6. Notice how from 1 to 4, 1, 2, 3, 4, it's going to be 4 terms that we're adding up together. And then from 3 to 6 is still 3, 4, 5, 6. It's still 4 terms that we're adding up. This time we're just going to go with 2k. So it looks a little bit simpler, at least the general term does, than the previous one, but we're not starting here at k or n is equal to 1. Notice, however, though, that k and k appear both as the index of summation, and then also right here in the general term. If we wanted to evaluate this, all we would need to do is write down our first term, which is just 2 times 3, or 2k, again starting with 3, that's our start value. And then we're going to do 2, that 2 is staying the same, k is the one that's changing. The next integer up is 4. And then the next one would be a 5, so it's just going to be 2 times 5. We need to go all the way to our upper limit of 6. If we take a look at this, that's 6 plus 8 plus 10 plus 12, and we actually get the exact same thing we did before. So there are many different ways that you can write a series in sigma notation. Sometimes it's necessary to write it down here with the lower limit being 1, and other times it's fine maybe to simplify your general term, but then you're probably going to need to change your starting value and your ending value.